Hey team, it's Mr. Munro here to talk about AO3 Expanding single brackets. Before we look at the algebra of this question, I just want to go back and talk a little bit about arithmetic to make sure we understand what the purpose of the brackets is. The brackets serve to keep information together that needs to be kept together and keep information away from other information that needs to be kept away from other information. Let's look at this question here as an example. So what this question states is that you need to add the 3 and the 7 first and then multiply that by 2. Now that's distinctly different from how you might write this without the brackets. If you wrote it without the brackets, what you might have is 2 times 3 plus 4. And what the brackets serve to do is just to keep that information separate. This is a shorthand way that we have come to agree as mathematicians as a way of writing this, as opposed to writing 2 times 3 plus 4 and saying this to make sure you add the 3 and the 4 first. We as mathematicians have agreed that if you write 2 bracket 3 plus 4, the multiplication is implied. So whenever you see a situation like this, what's happening here is the 2 is multiplying by whatever's in the brackets. Let's have a look at a sort of a visual example of what that looks like. So if we look at this geometric box here, you can see that what we're doing is we're going 2 times 3, 2 times 4. Now, I can actually add these together, right? I mean, quite logically. 3 plus 4 is 7. So what I'm doing is 2 times 7, that's 14. I'd have 14 squares here. But in the same context, you can leave it unseparated. You don't have to add the 3 and the 4 together. You could do it as 2 separate multiplications. You could do it as 2 times 3 and 2 times 4. So 2 times 3 is 6, 2 times 4 is 8, and then if we add those values together, we end up with 14, the same as here. Now, in real life, you wouldn't do that. You would add those together, make it 7, and go 2 times 7. But sometimes in algebra, we're not able to add those values together because one of them, like in the example over here, might be an unknown. Remember from one of our previous discussions, an unknown is a value we don't know the value of yet, and it's often represented with an algebraic or with a alphabetic or with a Greek symbol like an X or a theta or something like that. So let's have a look at what this visual example here would look like, thinking about what we've looked at over here. So we've got 2 on the left-hand side. You're going to have 3x here, and you're going to have 4 here. So when you're expanding single brackets, what you're doing is you're essentially removing brackets. I like to say, taking the cat out of the bag. So what we're going to do is we're going to do it in its separate parts to begin with here. You are going 2 times 3x to begin with. So 2 times 3x, 2 times 3x is going to be, well, I've got x here, and I've got x there. So 2 lots of 3x is going to give me 6x. And 2 times 4 is going to be 8. And that put back together, it's going to be 6x plus 8. That's a sort of a geometric representation of this. If we want to simplify it, if we want to do it just quickly, mathematically, algebraically, what you're essentially doing is you're going 2 times 3x, 2 times 4. You're going to end up with that same answer. It's going to be 6x plus 8. So that's the skill we're looking at today. It's expanding single brackets. When we are expanding, we're taking it out of the brackets. The opposite of expanding is factorizing, a skill that we'll look in our next video, AO4. So let's have a look at our next question. Next question is 3 bracket 4x plus 5. So I'm going to go 3 times 4x to begin with. So 3 times 4 is 12. So 3 times 4x is going to be 12x. And then I'm going to go 3 times 5 is 15. So 12x plus 15. It's worthwhile pointing out at this point that we're going to leave this like it is because we can't simplify it. In one of our previous lessons, we looked at simplifying like terms. 12x and 15 are not like terms. One's a value of x, one's a value of numbers, an integer. So we can't actually add these together. So we're just going to leave it as it is, 12x plus 15. Okay. Our next question is 4 bracket 7x minus 2. Now, you might have noticed something a little different in here, something we have to be a little careful of. It's this guy right here, this minus 2. It kind of makes us a negative. Let's do the first part first. So let's deal with the unknown, the coefficient. So we're going to go 4 times 7x. 4 times 7 is 28. So 4 times 7x is going to be 28x. And now we're going to deal with this minus 2. So what's going to happen because this is a minus 2? So we're going to go 4 times 2 is 8. 4 times minus 2 is minus 8. So this is going to be a minus 8. You can treat it one way or the other. You can treat it as minus 2. Or you could treat it as simply a 2, which is then being subtracted. Up to you. Either way works. What about in this question here? Just add a little minus in there to just make this question a little bit harder. Let's run through this one and see what we think. So I'm going to go minus 5 times x squared. Now from one of our previous videos, we talked about how this does the same thing as just a general x unknown. So 5 times x is 5x. 5 times x squared would be 5x squared. This is a minus 5x. This is a minus 5, so this is going to be minus 5x squared. And what's going to happen here? Minus 5 times 4. Whenever you've got a negative times a positive, you're going to still going to be a negative. Like 1 wrong makes it wrong, 2 wrongs makes it right. It's a terrible analogy, but anyway. So minus 5 times 4 is going to be minus 20. 5 times 4 is 20, so minus 5 times 4 is minus 20. Worthwhile briefly discussing the fact that if this was minus 5x squared minus 4, well, then the answer would be slightly different. It would be 5x minus 5x squared plus 20, because those two kind of cancel each other out. Two negatives make that positive. But anyway, so that is expanding. Single fractions. Expanding single brackets. So now's the time for you to have a go at answering one of these questions yourself. Here is the question that I want you to attempt on your own. So the question is 6 bracket 5x plus 3. So now would be a good time to pause this video, have a go at answering this question on your own, and then once you've done that, I'll go through and explain the answer. All right, off you go. All right, so you've had a go at answering this question yourself. Let's go through and see how it's done. So first part's first, 6 times 5x. So 6 times 5 is 30. 6 times 5x is going to be 30x. And next part, 6 times 3. 6 times 3 is 18. It's a plus 3, so it's going to be plus 18. So there's your answer. Let's try one more question because we're a pretty capable group of students. Let's try something a little harder. Let's go for minus 8 for y minus 2. So I want you to have a go at answering this question for me. I'll just drag this back up so you can keep an eye on what's been going on up here. So I want you to have a go at answering this question for me. Pause the video, give it a go. All right, the answer to our tricky left field question here. So we're looking at minus 8 4y minus 2. Let's start with this part here, minus 8 times 4y. So 8 times 4 is 24. No, what am I doing? 32. Now 8 times 4 is 32. So that's going to be 32y, and it's a minus, so that's going to be minus 32y. Moving on to the next part, we're dealing with minus 8. Let's just get rid of that. Minus 8 times minus 2. 8 times 2 is 16. There's a minus there and there's a minus there, so those are actually going to cancel out. So instead of being minus 16, it's just going to be plus 16. So here's our answer. So hopefully you're able to answer those two questions correctly. If you were unsure how to do those, or if you made a mistake on those, feel free to watch back through the video. If you are still finding it a little challenging, also feel free to come and discuss this with me. Obviously at any time. Feel free to discuss it with any of your classmates as well. I'm sure they'll be more than happy to help you out with that. So that was AO3 expanding single brackets. Well done. See you next time.